Today, we are going to tear down a real GCSE maths question. And not just any question, a big one, a whopping 5-marker. Now, I know these probability problems can look a little intimidating, but honestly, it's all about having a clear game plan. I'm going to show you exactly how to break it down, step by step, so it all makes perfect sense.
So here's our plan of attack. First, we'll look at the challenge itself. Then, we'll decode what the question is really asking us. After that, we'll figure out the winning scenarios, the combinations that actually work. Then, we'll calculate the odds, and finally, bring it all home for the final answer. It's a nice, logical path straight to those 5 marks.
All right, let's dive into Section 1. First things first, before we start solving anything, we need to get a really good handle on what the problem actually is.
Okay, so here is the exact wording straight from the paper. There are only 4 red counters, 3 yellow counters, and 1 green counter in a bag. Tony takes at random 3 counters from the bag. Work out the probability that there are now more yellow counters than red counters in the bag. That last part is the absolute key. What's left in the bag is what matters.
So, let's just lay out the facts so they're super clear. We are starting with 4 reds, 3 yellows, and 1 green. Add them all up, and that gives us a total of 8 counters in the bag. Remember that number 8? Because it's the foundation for all our calculations. On to our next section, decoding the goal. Look, this step is all about interpretation. Before we even think about touching the numbers, we have to be 100% sure we know what the question wants from us.
And really, this is the 5-mark question, isn't it? What combination of 3 counters does Tony need to pull out of that bag to completely flip the situation to make the yellows suddenly outnumber the reds that are left behind? Let's really think about that.
This makes it crystal clear, right? We start off with more reds than yellows, 4-3. Our mission, should we choose to accept it, is to end up in a world where the yellows left in the bag are greater than the reds. So the only way to do that is to make sure Tony takes out a whole bunch of red counters.
Which brings us right to Section 3. And this, honestly, is the absolute secret to cracking these kinds of problems. You have to figure out every single possible way you can succeed first. We'll call these our winning scenarios.
So, just to be super precise, a winning scenario is any 3 counters Tony picks that leaves us with more yellows than reds. If a combination he picks doesn't do that for us, we can just completely ignore it. Simple as that.
Okay, so let's actually test out the main possibilities. What if he takes 3 reds, RRR? Well, we started with 4, so that leaves 1 red, and he hasn't touched the yellows, so there are still 3 yellows. Is 3 greater than 1? Yes! That's a winning scenario. Okay, what about 2 reds and a yellow, RRY? That leaves 2 reds and 2 yellows. Are the yellows greater? Nope, they're equal, so that's a no-go. How about 2 reds and a green, RRG? That leaves 2 reds and 3 yellows. Yep, that one works. And finally, a red and 2 yellows, RYY. That leaves 3 reds and only 1 yellow. Definitely not.
And would you look at that? After all that logical thinking, this whole big problem boils down to just 2 ways to win. Either Tony takes all 3 red counters, or he takes 2 red counters and the 1 green counter. That's it. These are the only 2 situations we need to calculate the odds for.
All right, Section 4. We have done the heavy lifting, the real brain work. Now it's time to actually crunch the numbers and figure out the probability for each of our 2 winning scenarios.
Let's start with the easy one, taking 3 reds in a row. So for the first pick, there are 4 reds in a bag of 8 counters. That's a 4 out of 8 chance. Now, 1 red is gone, right? So for the second pick, there are only 3 reds left and only 7 counters in the whole bag. So that's a 3 out of 7 chance. And for the third, you got it, 2 reds left, 6 counters total. To get the chance of all 3 happening one after the other, we just multiply them together, which gives us 24 over 336.
Now for our second scenario, taking 2 reds and a green. This is where people can sometimes trip up, so let's go slow. Let's first calculate the probability of picking them in one specific order, say red, then green. That would be 4/8 times 3/7 times, well, there's only 1 green one, so 1/6. That works out to 12 over 336. But, and this is a huge but, who says he has to pick them in that order? He could pick red, green, red, or green, red, red. There are 3 different ways he could end up with that same handful of counters. Each of those orders has the same exact probability. So we just take our answer, 12 over 336, and multiply it by 3. That gives us 36 over 336 for this scenario.
We are on the home stretch now. Let's move to the final section, bring it all together, and claim those 5 marks.
So, because either the first scenario can happen or the second scenario can happen, we just need to add their probabilities. In probability, the word or almost always means we need to add. So we take the chance of getting 3 reds, which was 24 over 336, and we add the chance of getting 2 reds and a green, which was 36 over 336. That gives us our final answer, 60 over 336.
And here is a fantastic piece of exam advice, straight from the official mark scheme. You could write 60 over 336 on your answer line and get full marks. You don't actually have to simplify it. But if you wanted to, it simplifies to 5 over 28. They would also accept a decimal, like 0.18, or even a percentage, 18%. Any of those will get you the full credit.
So there you have it. That's how you break down a big, scary-looking 5-mark question. And I'll just leave you with this final thought to chew on. Why is it so incredibly important to sort out those winning scenarios with logic before you ever start multiplying fractions? Well, it's because with complex problems, getting the logic right is the foundation for everything. If you build that strong foundation first, the math just, well, it kind of takes care of itself. Definitely something to remember.